We're going.
Yes, hello everyone. Good morning. So my name is Athanasios Kouloumvakos and I work at APL. So today I'm going to talk about PyThea. So this is an open source software package that can be used to reconstruct the 3D structure of coronal mass ejections and shock waves, and also determine their kinematics using remote sensing observations. You can find this package on GitHub. This is where I have the source code of the package. This package has been developed purely in Python. It has some dependencies. So for the computational part and the numerical and plotting part, the main dependencies are those. So we rely on NumPy, Pandas, SciPy, and Matplotlib. There are also some other dependencies, mostly on the coordinate conversions, the image processing that we use, and the data download and fetching from a virtual solar observatory. So we also use AstroPy and SunPy for all these things. And there is also a dependency on Streamlit. So Streamlit, it's a package that allows me to develop PyThea and all the modules and utilities that I have in there, and put them in a graphic user interface that can be used, as I will show later, to make the reconstructions. So I will spend some time showing a few details in the PowerPoint of how the things are and how we construct, how this package is constructed, and then I'm going to show you on the web how the graphic user interface looks like, and we're going to play around with the tool. So with this package, as I said before, we can reconstruct coronal mass ejections and shock waves. So CMEs, they are large expulsions of magnetized plasma from the sun's outer atmosphere, and you can see an example here of how a coronal mass ejection looks like. This is a spectacular eruptive phenomenon that it's observed in the solar corona, and CMEs are the main drivers of space weather. And we also can reconstruct with the package shock waves. So CMEs, of course, can release a huge amount of plasma, but they can also drive shock waves in the low corona and interplanetary space. You can see an example of an eruption that it has a shock wave, and I'm going to point where it is so you can have an impression of this phenomenon. So here it's this bubble here. It's the propagating shock wave in the low corona. Well, it's a propagating wave, but if it's fast enough, it can steepen into a shock wave. And of course, all this can have a significant impact on ground-based and spaceborne technological systems when they can, since they can accelerate particles into high energies, and the CMEs can drive also geomagnetic storms. So our knowledge about CMEs and shock waves has significantly increased over the past decade with all the instruments we have observing these phenomena. This is another example of how this phenomenon looks like in the corona. So here in the middle, it's the sun. This is so in the middle we have the EUV imager. An imager that observes the sun at the extreme ultraviolet, and the outer field of view, it's a coronagraph. And you can see here the coronal mass ejection and the wave that it drives. And in most of the cases, this wave can become very broad in the extent. Okay. So this is overall an active area of research, and the better understanding of this phenomenon helps to elucidate the processes involved in other associated phenomena. For example, as I said before, in most of the energetic CMEs and shock waves, we have also solar energetic particles coming out, and this is one of the main research areas that I work on to make a relationship. To relate shock waves with solar energetic particles, and all the reconstructions and what I'm going to show, it helps us a lot to understand all these things. So how we do the reconstructions. So we want to model essentially CMEs and shock waves in 3D, determine their position and their kinematics in space. So this is an example. So we have the CME. So we're taking simultaneous images from 3 different spacecraft. In the past, we have all of those 3, stereo B, SOHO, and SDO, and stereo A. Now we are missing stereo B, unfortunately, but we can do the reconstruction in 2 viewpoints. So here we have the CME. And we use these 3 viewpoints to essentially model the position of this structure in 3D. And then, okay, we use this, and then we can also use these 3 viewpoints to fit into the images the shock wave. So we have, as I will show later, one model, the graduated cylindrical model. This is how we call this model for the flux ropes and the CMEs, and an ellipsoid model. This is the model that we use for to model the shock waves in 3D. Okay. And this is in time how the shock wave propagates and how we reconstruct it. Okay, so a typical workflow of the package is first to the package downloads the data. This process is automated, so we use.
C'è questo coso che voglio capire.
A microphone, it's open. Thank you. So so Pythia downloads, so we select a date, Pythia downloads the data and prepare the images and visualize them. Then we have to do the geometrical fitting. So the user goes and fits the model into the images. This process goes from one image to the other, and when the process finishes, we have fittings in time, and we can view and save our results in a table, a JSON, and we can export them and use them for any other reason. And one of the final products that we have here, it's of course the images where you can visualize your model on top, and this is how you do the reconstructions. But also you can have the kinematics of the shockwave or the CME in any direction. So apex and the 2 other axes in this case here. So as I said, we have 2 models, one ellipsoid model to fit shockwaves in 3D, and the graduated cylindrical model to fit flux ropes. And this is how the application looks like. So I have built this application in Streamlit. So we have one panel, the left panel, which is it's mainly used for the inputs, where you have the different sliders there. You can adjust the parameters of your model, and everything gets updated on the right panel, where I have mainly the products. So as you will see, we have there the images, and we can adjust from the slider the different, we can change the different images, proceed with the fittings, and also visualize later the kinematic plots, or extract you know, the fittings in the table and have the fittings in the table. So this is a quick view of the different options that you will have. So this is a set of parameters that we will adjust. We have an imaging menu where we can select the different images to load and download. We can select different times to do that. We can select through different processing options, running different different images. We can play around with the visualization, also change the image C limits, the column map limits, and that's it for this thing. So enjoy your fitting. Don't forget to put a star in our repository if you like and use the package, and you can find there many details of how to install it through PyPy and many other stuff. So now I will go to my I will change my view and I will go to my web browser so I can show you in detail how the tool is. Oof. Give me a second. So, okay, let me select desktop. Okay, can you see now my full desktop?
Yes.
Okay, super. Let me extend this. Okay, so this is how the tool looks like, but okay, I will need just one more seconds because I want to show you how I run this from the command line. So yeah, when I first launch my script, so streamlit run PyThea, you will, okay, we go to the browser. Okay, and this is the first page that it loads. So in here you can select your event. So if you are interested in a specific date, you can go in there and select your date. So we will go to this one. So when we select the date, the tools connect to a database of flares, and we can select the flare that we are interested in to work on. So let's say that this is the flare that we want to analyze. And then we have to select our model, so spheroid, ellipsoid, and GCS. I will go through the ellipsoid. So now the tool starts to download the data. I have already done that, but the tool will skip those data since they are already in there. Or well, it downloads some more data. Maybe I selected a different flare, a different flare. Nevertheless, and when the the data gets into our database, the image will view in here. So let me go to the web that I have already downloaded the things. So let's say we want to analyze this event where we had this CME. So I can select here through the different imagers and can go through time, visualize the images. So this is an image from a coronagraph. The sun, it's in the center. Here it's my model. This is the ellipsoid model that I saw there. And I will adjust now the location of this model, and my main point here is to fit the ellipsoid into my shockwave. So I know from previous fitting that, okay, my shockwave was real around this location. I will adjust the latitude. So here I adjust the latitude and longitude of my ellipsoid. Then I will adjust the height and the other geometrical parameters. And I want this to fit almost perfectly, you know, the shape that I have in there. Well, this process can take some time, but I will assume here that this fitting is okay the way it is right now. So I can proceed, and I will store my fit. So I have already stored one fit. I will go here in the options. I will view the table with the fittings. So, yeah, I forgot to mention that if you already had a fitting, you can load your previous results and work on those. So all these things here in the table are my previous fittings. So essentially, since I have already had one fitting, it should take my parameters for this fit. So at this time, and it should go in there and put the new parameters, updating the table. And as I said before, if I am happy with the fitting, I can proceed. When I have fitted different times here, I can proceed and view my kinematic plots, which right now they don't appear really well. Yeah, maybe because I fitted this wrong. So I will just erase this fit here, 23. Okay, so this is a view of my kinematics. So every point here is just one fit into the images. So I fitted this image, then I will fit the next one and the next one. Usually the process, this is a 3D process, as I said before. So we want different imaging data from different viewpoints so we can get the best out of this process and locate our feature
So this guy has been
good.
called PyHC. Heard of this before?
You have open microphone. Sorry.
And what you do is
So you can have here the different viewpoints. So we can supplement this thing with some other with any of the available images that we have. So we can select here through a list of different images. And every time we will select a new one, the data will download automatically, prepared and visualize them. And so if you want simultaneous fittings, you will go select your main imager, and through this option, for example, supplementary imaging, you will have another 2 imagers to do your simultaneous fittings. So in this case, we will have, for example, from LASCO C2 and LASCO C3. And so what we want here is everything we see here. To if we fit, for example, this image and say that we have this fitted like that, we want to be equally well in this viewpoint. Okay. And that's it. Let me see if I have any other cool feature to show you right now. So we can, as I said before, we can adjust the limits of my column maps and do it like that, play around a little bit with this view. I can clip on or off the image limits when this ellipsoid passes out of my field of view. I can also recognize bodies or spacecrafts at the images. And well, this is not a feature that I usually use, but this is a really cool thing when you have a bright object inside your field of view and you want to see which planet it was. And I don't know if we had at this day anything inside. No, but if we had a planet and if I go through this option, you can see, yes, we don't have anything here or there. But if we had, you know, the tool here will recognize your planet or your spacecraft, and you will say, oh, yes, we had, for example, Venus or other things inside. And what time is it? It's at 15 February. Oh, okay, so we may have, for example, a Parker or Solar Orbiter. Let's make a test. No, probably not, or else we would be able to see those points here. Okay, nevertheless, you can play around with this thing also. And when you have performed your fitting, you were ready to visualize. You are ready to visualize, for example, your kinematics. You can play around here and fit your kinematics with the different models, spline, polynomial fitting. and all this stuff, and you are happy with what you have performed, you can download your fitting in a JSON file, and you can use it. Later. And just to show you how to do that, it will take me just a few minutes. You go there, select file, browser files, select your JSON file that you have just downloaded, upload, and everything will gets uploaded, and you can continue with your fittings, update them, visualize them, and do whatever you may like to do. And I think that's it. I will stop here, and I will wait for your comments, questions, and whatever you want.
It looks like you have a bunch in the chat. So to begin with, Will, it looks like you're plotting the LASCO images using SunPy / I don't know how to say that acronym, WCS axes. How are you overlaying the CME trajectories / structures on the maps? Are you constructing these using SkyCoord objects, or is this all done in pixel space?
All right, so no, this is, let me see. Oh yeah, so yeah, we construct inside, so we select our geometrical model. So let's say this is, for the CMS, it will be the GCS model. So for this model, we have defined a mesh of points, and we take those points, we convert them using SunPy, correct? We convert those points into sky coordinates. Objects, and then we use SunPy to project those points into our imager by using I think coordinates to pixels. So the last visualization, yeah, goes like that. And well, here I don't have the mesh of points. I only have the skeleton, let's say, of my model. This helps me to fit, you know, the outermost things on the images. But you can go in there and have your mesh, and the visualization part, it's the same, even if I use one or the other. So yeah, every this mesh of points has a specific coordinate, and I use SunPy to do the visualization part. And okay, the next question is, how does this compare to StereoCut? Let me see StereoCut, because yes, okay, I think the logic, it's well, I haven't used this one. But if the logic of this tool, it's similar to what we had in the past, what we have with IDL, then it should be, the logic is similar. So it's similar to what we had for the what we had from IDL. And let me see the other question. Yeah, so yeah, my answer to how does this compare to a Ternesian model? Yes, essentially the geometrical model, it's the same, because for the GCS model, I have taken Ternesian routine and converted into Pythia. So in principle, all the parameters used for that model, it will be the same, and that's it. So, and the visualization part, it would be the same too, but I constructed it everything from the beginning without the going through the IDL, the RTC cloud. But I think it's the same. You start from space coordinates and you go into pixels. Can the tool be used online without without downloading the data? Used offline, you may mean. So offline, not yet, but there is a plan in the future to make this work offline. So yeah, essentially to work with this, you need a net connection. So the tool will the tool uses SunPy and Fido to connect to VSO, sets the data. If you have the data, then proceeds. So you have to be connected on the net. If you're not, then you cannot load it. And in the future, maybe we will do an offline mode. If you already have the data in your repository, you can say, okay, go there, see the data, and proceed without searching again. And okay, what does Pythia do in the cases of data gaps? You probably mean data gaps with the images. So, well, if we have, if we don't have simultaneous image and there is some missing image, then we have to proceed by fitting this image without having a pair of images. But feel free to ask me again if this was not the case. And nice talk, really cool tool. Thank you for the nice words. Does Pythia also prep LASCO data after downloading? No, it uses directly. So essentially, most of the data, they are at level at least 1.5 because they come from VSO. So I do a minimum of processing here. So normalization of the exposure time, and maybe some other preparations that I don't remember right now, in which case I do what. So I do a minimum preparation of the images, but to get level 2 images, you have I don't offer something about it, but we have to, in the future, there is a plan to increase the level of the data, or if there is a provider that give us a level higher than VSO, we can just fetch those data from another provider. But I think VSO and the data that we have already, it can let us do the job. And because in most of the cases we use running and base different images, it's okay. I think it's okay, the level that we have from VSO. Another question, we have a...
Yeah, go ahead, Rebecca.
Hi, thanks for the talk. The question I had in the chat about tool being used online is more for people that don't have access to a lot of data storage or may not have any data storage to talk of. Could they use your tool online without downloading the data and maybe just download like the resulting speed plot, if I recall the axes right, like the output plots instead of the images? Like, can they run this on the cloud?
Yes. Okay. So let me see. Okay, so to go directly to this part, so the kinematic plots, instead of loading the images. No, I think not, but I had a plan, because if you have, for example, the same structure, a JSON file that it has the fittings, and you only want, you don't want to visualize essentially the images, or to have these panels, and you only need to visualize the fitting table and the kinematic plots. So yeah, there is a plan to skip this part and go directly to your kinematic plots and do whatever stuff you would like to do. So yes, my answer is in the future, a feature like that would be useful, and just to skip the part that you already have performed, that's the fitting, and go directly to the kinematic. So yeah, that would be cool, and I will note that down. What else? Pretty good. Another, is the Streamlit separate from Pythia such that Pythia could be used in a Jupyter notebook without the local web server from? Well, essentially, we are not using Streamlit web server. We use the local thing. Yes, I will agree. The way that I have constructed some of the modules and the utilities, in principle, that utilities and the modules could be used, yes, to use this at a Jupyter notebook, but that would mean, some you have to go through the modules, see how a few routines are constructed with the downloading part and some of the visualization part, take the relevant parts and bring them into the Jupyter notebooks. So I have tried to make it separately, so to have separate some utilities that can be used out of the Streamlit idea, and some modules that they can be used only in Streamlit, and how I construct the GUI. So in principle, with some extra work, yes, someone could use many of the utilities to bring inside this visualization stuff in Jupyter Notebook, yes. Anything else? Comments, ideas?
Any other questions? Awesome. Well, thank you.
Thank you too.
Excellent presentation. Really cool sounding project. I would, maybe consider adding it as a PyHC project. I don't think it currently is, but it certainly has a lot of utility within it.
And something last. So we are planning on releasing a paper soon for this tool. So it will be on the Frontiers special issue. So when the time comes, I will let you know, so you can read in this paper some of the details and how we constructed a few things. So by then, feel free to use the tool, and if you have any comments, issues, or ideas, feel free to to post something at the GitHub, and time permitting, we will try to do anything. Super.
Sure.
Are you talking about the snakes on the spaceship Frontiers call?
Yes.
Nice. We're submitting a paper to that too.
Super.
Yeah. You have two different questions. Okay. I think Laura's question in the chat came up first. Is there docs available somewhere for Pythia?
Well, not yet, but yeah, because when now we are at version, which version we are now? 0.6.6, I think, and we have some work to do up to version 1. So one of the tasks that they are going to be in the future is to build some tests and some docs, but right now, because we are let's say our funding is limited, or we are in a search of some funding, at least for these two parts, the testing part and the doc part, it has to wait a little bit until we find some funding to do this. Anything else will be well, I mean, the maintenance of this package will be ongoing, but at least for these two, because it needs some a good amount of time to prepare those things, this has to wait a little bit, just a little bit.
Awesome. Go ahead, Rebecca.
And being good, I raised my hand. That I would recommend, looking through copying the chat and addressing those questions in the paper that you submit, because any reviewer is going to ask the same thing. So just preempt it, do the comparison between your tool and SolarSoft and your tool and StereoCat and vice versa, and argue why this should be a thing, right? But just preempt the reviewer's comments.
Yes, that's a good call, and well, my answer to that is okay. The models are the same. The geometrical models, I mean, the parameters are the same. So the images are the same because we use the same data. So the only, let's say, part that we could have a difference, it's because all these things are user dependent. So if we bring this aside, that me as a user can have different results to another user. So the only difference would be the coordinate stuff. And I think because we rely on the coordinate conversions into the SunPy, and I know that in SunPy there are a lot of tests to be consistent to what we have from SunPy to IDL and all the comparisons between those two to be the same, to be consistent. I think the only part is this. So if something would be different, that would be the case. For the geometrical processing. And another difference might be the quality of images. So if someone uses IDL, maybe he can do one level processing up with one of the preparation routines, so LASCO prep, stereo prep, and all this stuff. And okay, this is something that needs to be done in the future, so to have a level 2 data, and at least visually the data will be better. On the other hand, anything else I don't expect to change. I mean, in the coordinate conversions or the coordinate systems.
Well, here's a thought you could include in your paper. Because this tool is written in Python, it's written in the same language as a lot of the machine learning processing tools. So it could be incorporated in someone's workflow with the machine learning tools. That's as far as my brain goes on machine learning, though. So there's an argument for. There you go.
Super. And how I copy the chat? Does anyone knows how to do that? Select all, copy. Okay, thank you.
There you go.
Awesome. Well,
just for posterity, we always include the text of these Zoom recordings where we keep the video too.
Yes. Perfect. Well, thank you again for the presentation and to everyone for all the awesome questions. If anyone has any more questions that pop up later, I'll make sure to include Athanasius' email in the notes that I write up for today. So thanks again. And now we have about 19 minutes. I just wanted to quickly go over some of the decadal survey white paper ideas that we had come up with a few months ago at this point. We finally have a bit more of a timeline to go off of. It looks like the call for white papers is expected to come out on or near June 15th. So that's just in like 2 days, with a due date 2 months after, so mid-August. I can just share my screen with the document where we've done this before. Okay, can everyone see it?
Yes.
Okay, cool. So I guess the best way we can just go through the general, headline here and see who the interested parties were and see if those are still the people who are actually interested. So yeah, the first one we have is research software engineering as a career path within heliophysics. That was first suggested by Ian Cosden at our Telecon like a year and a half ago or so, talking about the US research software engineering. And the people who had been interested at the time, at least in leading some kind of white paper, were Nick, Rebecca, and Kevin Bearden. I think we have Nick on as well as Rebecca. Are you guys still interested in leading this kind of white paper, or yeah, thoughts?
Yeah, Nick, you want to help? You want to co-do this? I have a few pages of research. I just haven't had time to get my brain around to do a draft. Nick? Okay, well, it's enough update, I guess, for now that I have a couple pages of notes from some CCMC meetings to kind of bounce off of them, because there are a bunch of software people there too. And we even have notes. We have connections to, his first name is Sky. I can't remember his last name, but he's at USGS. And he's interested in being a contact point for us to bounce off of him, because they're doing the same kind of thing in that company. It's going to be at least the end of the week before I can touch this, though.
Okay, so it sounds like that one definitely still has interest.
I know there's another. I mean, my interest, I guess, way back then, was there's another white paper people are working on sort of the soft money career path in heliophysics, and how to support those alternate, funding and project paths and career. It seems like somehow this sort of might tie into that as well.
Mhm. Okay. Good to know. Let's see, the next white paper idea.
Kevin.
Oh, go ahead.
Yeah.
I'm going to copy down the names. I don't have, Kevin, would you mind putting your email in the chat, or would you want me to put mine so I can keep you in the loop on this?
I can do that. Yeah.
Okay. Is Ian Costin here?
No, I don't think so.
Do we have his contact information?
We should. Let me make a note to look for that and get that to you.
Ian
Yeah.
Costin. Yeah, I just
Yeah.
talked with him like last week, so
Oh, there you go.
I can reach him.
Yeah, let's pull this together. How about Nick? We figure out a date between you, me, and Kevin, and meet at the end of the week and try to pull this together. I'm hoping to do a draft on Thursday or Friday morning.
That should probably work.
Okay.
Good work,
Kevin,
guys.
sound good to you?
Yeah, that should work.
Okay.
Thanks.
Okay, cool. Sounds like that one will be moving along nicely. The next one we have is atomic data needs and accessibility for heliophysics. I don't quite remember exactly what we meant by the first part of it, but the interested parties, I don't think we have Alec, but we do have Sean and Nick, of course. Would you guys still be interested in being involved with a white paper of this topic?
Yeah, I'm trying to remember what the paper right below that bullet there was, the ongoing development and support, blah, blah, blah.
Uh-huh.
So I was a co-author on that paper, the one led by Yami. And I believe Nick was as well, maybe. So we had also had a poster at the Heliophysics 2050 meeting. What was that? Sometime last year. So yeah, I mean, the basic idea was just that was kind of focused on mostly the Chianti atomic database and other associated atomic databases, and basically like advocating for some sort of unified framework for combining different atomic data sources and then exposing some sort of software API for them, but at a almost even a higher level than that. I think if we wanted to extend that paper, we should also reach, there are quite a few people on that paper that's linked there that we should probably coordinate with them as well. I know there was some interest, at least from myself and maybe others, about actually submitting a decadal paper on that topic.
So I'm hearing correctly that the paper that we have linked there is already done. You guys finished making that one?
Yeah, that was written for the 2050 meeting last year.
That was last year.
So yeah, I think if you click on that link, I think it goes to the, I created a Zenodo repository for a lot of these Helio 2050 papers that I think a lot of people ended up submitting them to. So I believe the PDF of it is there. And then we expanded on it a bit for for that meeting. There was a poster as well that I led.
Well, I'm not sure how I would keep the ball rolling on this one, but especially if you guys already have a group that have worked on this paper, and if you're considering forming something similar for the decadal thing, I'd be happy to throw my name in there.
Okay.
It would help a lot to not be first author like I am on my current paper.
Sure. Yeah, I think so. The group that wrote this paper we have not coordinated much in the past year, but we probably should, it's been an item on my to-do is to kind of round up everyone again to see, okay, what changes do we want to make to this draft? Do we want to just submit this as is? You know, what else do we need for the decadal? So I can ping everyone on that author list and then kind of post back as to what the status of that is.
Yeah, and I mean, I'm sure you have my email somewhere. If not, I could give it to you.
Yeah,
Maybe CC me in that correspondence or something.
sure.
Nice.
Nick, I don't know if you know anything more about this as well, or have had any thoughts on this.
Haven't heard anything new. Still happy
Okay.
to participate.
Okay.
Awesome. Let's see. So the next white paper idea is on making software interoperable, very in line with all of the things we've done in PyHC as of late. There are several different thoughts on this, but the interested parties were Russell, who was tentative at the time, John V, and Rebecca. Let's see. We have Russell, we have Rebecca. Would you all still be interested in being on a white paper of these topics?
Yes.
It's
But
a very
do I have
important
to
one.
lead it? If no one else will, I'll do it. That's kind of my mantra for the summer.
What say you, Russell?
Yeah, I'm here. I'm still interested. Yeah, I guess I could have time. I might be able to lead it, maybe, but I could certainly participate.
Okay, cool. Well, we have some definite interest in it, so we will keep
Is
this
John here?
No.
I
Does
could have
not-
asked him on Friday. I saw him in person for once.
Yeah. So, okay, cool. That one is still going strong then, for the moment at least, it looks like. The next one, Python and Heliophysics Community Overview. Summarize who we are, what we're doing, why it's important.
Julie, I nominate you to draft this one.
Yeah, my name's on it, so that makes sense.
You
Cool.
and Sean draft it up and we'll put our 2 cents in.
Sean, are you okay with your name being thrown on this? It's not currently there, but I think it makes sense.
If such a paper were being created, I should be involved with that. Yes.
I would agree. I would agree. Oh yeah, I even mentioned the Coast Guard paper, which is now completed. Cool. Okay, we can need to address reviewer comments, but other than that, we can use that to help jumpstart that white paper. Let's see the next one. It was Rebecca and Alec on this to build an online data model software discovery and analysis platform. This and the next topic have been merged into one white paper. Oh, so it's already made into one. What was the next one? Build an online searchable library system, searchable software and high performance computing services system. Rebecca, do you know much about this? The comments
Yes, I gave you the updates.
Okay.
I threw them
Okay.
in the document. So I have a draft and happy to meet about it. Just in 2 weeks, I'm swamped. I want to get the other white papers at least drafted so everything's on the same preparation level. So in
That's
2 weeks, like
understandable.
week after gym or something like that. In fact, I think this is going to be one of the ones that gets discussed at gym if I have my notes right. So if you're attending gym, make sure to attend the MMV sessions, metrics, models, and validations, or whatever it stands for. Wednesday afternoon? I don't remember.
Cool. Well, awesome. Let's see. The next one just had you, Nick, so far, but it's software sustainability for PyHC Helio software. How do you feel about still doing some kind of paper on that? Or maybe there would be someone else here also interested in leading that effort with you.
If it's me by myself, it probably won't happen. But I would be interested in still being part of this. This
Yeah.
one would probably go into funding models, so it'd be worth having some discussions about it with PyHC, like on one of these telecons, I think.
So Nick, do you want to pull this in as an argument for the software engineer, or like that paper up there? Like
Yeah,
as an
that-
argument for why it should be respected or that kind of thing. But I think it should be addressed as two separate things, but for lack of bandwidth, if we want to try to combine the two into one, or just, I mean, they don't have to be long. I mean, the max is 7 pages, so if it's just a 2-page thing, then
Yeah, I think my first inclination is that if there's enough interest, it'd still be worth doing something separately and focus on that. So like smaller, more manageable chunks, but that we can see in a few weeks how much interest there is. Anyone else interested in this?
I'll help if you draft it. I got enough writing to do.
Anyone else possibly interested in being involved with this kind of white paper? Okay. Well, Nick, I guess see how much time you have and kind of reference back to that first white paper idea that we talked about, like Rebecca mentioned, and then let us know what you're thinking moving forward. We can touch base on this again in the near future.
Cool.
Okay, educational resources. Educational resources, that's the white paper idea. A lot of educational resources are just in library and platform papers. See above, I'm assuming we're talking about those.
That might not be a good topic for PyHC.
Yeah. The only, your thoughts on this, Nick? It's just you and Rebecca who had slapped your names on this.
I think the PyHC summer school could be emphasized in a few of the other papers, like the PyHC overview and the RSA paper. So we might be able to pull the important bits from this and put them elsewhere. So yeah, I'd say I agree with Rebecca that it's not the most PyHC paper, but there are elements that we do want to make sure get said.
Yeah.
I know there's some other educational white papers. The best contact would be Jennifer Gannon. It's I actually have her email memorized for once. It's Gannon at CPI something or other. Well, most of the
Canon,
emails-
like canon, but with a G?
Perfect, yes. I can get her email kind of easy. In fact, I think it's in my thing, but she would know where to direct it. There's a spreadsheet. I think I copied the link into that document you have there. I'm not sure. But
Possible.
I think there's a white paper already going on. And if we're kind of like about leading it, then we could just join onto theirs.
Okay. Okay.
I'll post
Look.
the link to the spreadsheet in the chat if I can find it fast enough, or at least her email.
Yeah, either would be great. Either would be great. Okay, cool. So probably not gonna be a PyHC white paper, but it sounds like we may be able to kind of throw support behind one that is already being thought of. So that sounds good to me. We have a lot of white paper topics here. So let's see the last one, making data findable, accessible, interoperable, and reusable, following FAIR principles. The interested parties, Sean and I have question marks next to our name, and then there's Nick again.
So 2 comments,
Yeah.
particularly because we have so many white papers. We're only so many people, right? So I know Ryan's leading one that's pretty strong for this. This is also a component on the one we talked about earlier that I already have a draft on. Honestly, I would recommend either just sign your name onto one of the others, so we're not spreading ourselves too thin.
I would agree. I like that idea.
If anyone objects, feel free to lead it yourself. That's my thought.
Doing less work, I'm okay with.
I would
Yeah, we
agree.
can definitely support other groups.
We've
Cool.
also we've been looking a little bit too at just open science in general, which is you know kind of a superset of fair data principles.
Yeah.
So I think if we were going to throw all of our effort into something, we could broaden it out more than just that. So I'm happy with just taking a look at what Ryan and them are leading.
Yeah. I'm sure.
One thing
Ryan's,
to do that
go
might be
ahead.
really easy is like Sean, just write like a 2-page summary of the executable paper, and there's your white paper. That would be easy.
That's true. Yeah.
That could be a thing. And then we can all sign our names on this one and the others and whatever. But that would be easy for you to write if you can find the time. You can say no, by the way.
Well, you know, I actually am in the process of submitting the executable paper, doing that this week. So I will get back to you after I'm done with that.
All right. Think it over. Think it over. If you're stretched a bit thin, we have a lot of other white paper ideas that are pretty good here. Let's see. I think, okay, that's it. That's it for all of the white paper ideas, only a few. And we've run up to the clock. So cool. It sounds like we still have some interest in a lot of our white papers. So I guess consult back to this document again, see which things you've agreed to do and make sure that you're communicating with the other interested parties therein. And we'll touch on this again sometime in another future telecom before everything's due and see where everyone's at. So until then.
Hey,
Yeah.
Julie, would you mind making this kind of a routine thing until it's due? I mean, it's 2 months. We're meeting
Sure.
every other week. Just like give it 5
Yeah.
minutes. Like, yeah.
Yeah, we can do that.
Just every
There
time.
should be time at all of our meetings to include that. So let's do it.
Like I would think the next meeting, it would, like just 5 or 10 minutes to poke at people again, and then have more dedicated time to one after. And sorry, I am in complete logistical mode right now. I'll be quiet.
No, I agree with that idea. I think it's a good one. So yeah, we'll just keep checking in each telecom. Let's do that. That's a good cadence
Thanks,
to
Julie.
go for.
Thanks.
Sure thing. Sure thing. All right, cool. Well, that's it for today's telecom. See y'all again in 2 weeks, same time, same place. We're going to have an HDEE project intro and then some more discussion time. So
And Julie, won't I be seeing you in like a couple hours for a summer school debrief thing?
yes.
That's still happening today? Okay, cool.
Yeah, that's today. That's today. If you were someone who presented at that and for whatever reason don't have an invite to that meeting and want to be on it, let me know.
Should I come or is Asher coming?
Sure doesn't usually show up to those. It might conflict with another meeting in his schedule. I can add you to it and you can come and give your thoughts if you're interested.
What time is it? What time will the
It's-
meeting be for?
It's usually 12 to what? Yeah, 2 p.m.
2 p.m. your time?
No, your time.
Okay, maybe. Add me to the invite. Yeah.